Which of the following is not an isomer of octane? Well, that's octane. It's got 8 carbons and therefore 18 hydrogens, CnH2n plus 2. More methyl heptane. Let's have a look at that. There's the heptane, 1, 2, 3, 4, 5, 6, 7. There's the methyl off it. Again, it's got 8 carbons, no problem. 18 hydrogens. 2-ethyl hexane, that's what this would be. Now this looks like a perfectly reasonable molecule. Actually, it kind of looks like a long sort of lizard there with the front legs and the body and the tail with its head sticking out. But anyway, the head is actually the start of the longest chain, because here's hexane, 1, 2, 3, 4, 5, 6. But if we put the ethyl here, 1, 2, 3, 4, 5, 6, 7. So 2-ethyl hexane is this molecule, but it should be drawn as 3-methyl heptane. 2,2,4 trimethyl pentane is this one, 1, 2, 3, 4, 5 pentane. That's the 2 methyls at the 2, and then 3, 4 the methyl at the 4 carbon. C8H18, no problem. And 2, 2, 3, 3 tetramethyl butane is this molecule, 1, 2, 3, 4 butane, 2 methyls at the 2, 2 methyls at the 3 carbon. So this one's not an isomer of octane, because while it is the right molecular formula, there is no such compound as 2-ethyl hexane. It is indeed 3-methyl heptane. If you've looked at some of the questions associated with this, one of my favorite type questions is a student erroneously named a compound as blah. What should the compound be? Because then you have to draw it from their description and then look at the new drawing and name it correctly. So a kind of 2-for-1 question, always fun. And on the subject of fun, 18 structural isomers, C8H18. This is sort of fun, and you have to be systematic about it. You'd probably never see something this long on an exam, but it's a worthwhile exercise to get you thinking about structures. So anyway, C8H18, the way I systematically do it is I start looking at the long chain and see what's left. So if my long chain is 8 carbons, that's it. It can only be that. Octane. If on the other hand I have a 7-carbon long chain, that means I have 1 carbon left over, which would have to be a methyl branch. So therefore this is going to be some form of methyl heptane, heptane for the long chain of 7 with a methyl branch. Well, you can't put a methyl on the end of the heptane because that would make it 18, so you have to start your methyls at number 2. So I can put 1 at 2, I can put 1 at carbon 3, I can put 1 at carbon 4. If I put 1 at carbon 5, that would actually be the same as putting it at carbon 3. Okay, because if you think about this, 1 same as 7, 2 same as 6, 3 same as 5. So 5-methyl heptane would actually be 3-methyl heptane. 6-methyl heptane, putting it there, would be the same as 2-methyl heptane. So that's 1 octane and 3 heptanes. Now let's go to 6 carbons. If there's 6 carbons in my long chain, that means there's 2 left over. Well, those could be 2 methyls. So therefore any isomers like this will be dimethyl hexane. Now again, you can't put a methyl on the first carbon. You could put it on the second carbon, and then we've got another one, so let's put both on the second carbon. So the first one here would be 2,2-dimethyl hexane. Now let's keep it on the second carbon, but now move the second one to the third carbon to give us 2,3-dimethyl hexane. Now we can, instead of on the third, it can be on the fourth. 2,4-dimethyl hexane, and nothing wrong with sticking it on the fifth. So we've got 4 possible 2-something dimethyl hexanes. And that's it, because of course if we did 2,6, well, putting 1 on the 6th just makes it into a heptane. Now let's try putting the methyl group on the 3 carbon. Well, if we put 1 on the 3 carbon, we put the second one on the 3 carbon. So one of our isomers, 3,3-dimethyl hexane. Put 1 on the 3, 1 on the 4. So now we get 3,4-dimethyl hexane. Okay, can we put 1 on the 5? No, because if we put 1 on the 5, that would actually just be 1, 2, 3, 4. So 2,4-dimethyl hexane would be the same as 3,5-dimethyl hexane. So that's the end of our dimethyl hexanes. 1, 2, 3, 4, 5, 6 of them. Because remember, we had a 6-carbon chain. We said there's 2 carbons left off. Now I've said that could be 2 methyls, or it could of course be 1 ethyl. Now, if we think about where we put our ethyls, we can't put an ethyl group at carbon 1. One ethyl is just extending the chain by 2. If I put it at carbon 2, well, then that would just be extending the chain, because now the chain, as we saw on the last question, would start here with the ethyl group rather than that one methyl group there. So you put an ethyl group on 2, it's actually the same as making a longer chain with 3-methyl. So that means that the first place we could put an ethyl group is carbon 3, so 3-ethyl hexane. And of course, if I put it on 4, that's the same as putting it on 3. So there's only one ethyl hexane that's an isomer of C8H18. So we got 1 octane, 3 heptanes, 1, 2, 3, 4, 5, 6, 7 hexanes, so we're up to 11, 7 more to go. And obviously we now need to think about the ones with 5 carbons. So if there's a 5 carbon long chain, it means there's 3 carbons left over. And we could try those as 3 methyls. So we'll be looking at trimethyl pentanes. Now again, you can't put a methyl group on carbon 1. So we'll start with putting one on carbon 2. And then the first thing would be put a second one on carbon 2. Now carbon 2 is full, so we'll put the third one on carbon 3. So that would be 2,2,3, trimethyl pentane. Then, of course, we can keep the 2 on carbon 2. And now instead of the third one being on 3, we can put it on 4. So we get 2,2,4, trimethyl pentane. And we're done with having 2 on carbon 2. So let's keep 1 on carbon 2. 1 on carbon 3 and put the second one on carbon 3, so 2,3,3 trimethyl, or maybe put the third one, the last one, not on carbon 3 but carbon 4, so 2,3,4 trimethyl pentane. Now that's it with the trimethyl pentanes, because anything else you want to do, you're going to generate one of these we've already done. For example, if you tried to do 3,3,4, well, that's the same as 2,3,3. Okay, if you tried any 4,4s, well, those, of course, the same as 2,2s. So that's it with 3 methyls. Because with 3 carbons lacking, one could be a methyl, one could be an ethyl. So let's see about that. Well, the ethyl, remember, we can't put an ethyl on carbon 1 or carbon 2. So the first place we'd have to try for an ethyl group is carbon 3. Okay, now we can either put the methyl group on carbon 3 with it, so 3-ethyl, 3-methyl, or we can keep the ethyl in carbon 3, that's the only place it can do, and put the methyl on carbon 2. So we get, again, looks like a little skinny bug crawling, doesn't it? 3-ethyl, 2-methyl pentane. And that's it. The only place the ethyl can go is on carbon 3, and the methyl could either be on the same one, 3, or the next one, 2. If we put the methyl there, well, it's not 3-ethyl, 4-methyl, it's 3-ethyl, 2-methyl, and so on. So that's 6. We need one more that must come from a 4-carbon chain. So 4 carbons means 4 left over. Try that as 4 methyls. Well, the only places those 4 methyls can go are the 2 on the second and 2 on the third to give us 2,2,3,3 tetramethyl butane. Start putting ethyls in there. Well, remember, ethyls can't go on the 1 or the 2 carbon. Well, this is also the 1 or the 2 carbons. You can't put ethyls in there, certainly can't put propyls in there. So this is the only butane isomer of C8H18. Wasn't that awesome? Now you might want to go away and try and do nonane. And I can't remember how many there are, but there's lots more than 18.